Hello folks, this is Dr. Doug Young, and in this lesson I just wanted to kind of address a question that I hear from students a lot, which is what is the difference between the molar mass, the formula weight, the molecular mass, the atomic mass, all these different terms. And so I just want to quickly show you the similarities between them and the differences to just try to clear up the vocabulary here a little bit. So if you look at this, right, the idea is that all of these atomic mass, atomic weight, molecular mass, molecular weight, formula weight, all of these, they're really all talking about the same thing. They're all talking about the molar mass, right? They're all a type of molar mass, and remember that a molar mass is just the mass of 1 mole of something. The mass of 1 mole of a substance. And of course, by mole, we're talking about that Avogadro's number, that 6.022 times 10 to the 23rd somethings, right? So it might be the mass of an atom, it might be the mass of a molecule, it might be the mass of whatever. And then with under this umbrella of molar masses, right, you have these more specific terms, the atomic mass, molecular mass, and formula weight. They're more specific, but they basically mean the same thing, right? So the atomic mass or the atomic weight, it has the same units, right? It's still grams per mole. Sorry, I should have put that up here. This is, right, molar mass is also grams per mole. Molar mass is how many grams are in a mole. Atomic mass is the same thing, only atomic mass, like the name states, right, this is used for atoms. So just used for atoms, right? So when you have single atoms that you're talking about here. So when you look at the periodic table, right, we talk about how the atomic mass of oxygen, for example, is 15.99 grams per mole. So 15.999 in this case, grams per mole, and that would be the atomic mass of oxygen. And again, it's just talking about that individual atom. So atomic mass, atomic weight. Now, when people use the term molecular mass or molecular weight, it's still grams per mole, right? It's still a molar mass. It's still grams per mole. Only now you have the word molecular in front here. And just the only thing you want to keep in mind is that a molecule is a covalent compound. Sorry, when someone says molecule, they mean a covalent compound. And so the term molecular mass or molecular weight, sometimes abbreviated MW, is referring to covalent compounds specifically. So you would not talk about the molecular weight of an atom, because that's not a covalent compound. You would not talk about the molecular weight of an ionic compound, because ionic compounds are not molecules. They're not covalent compounds. And so this is just for covalent compounds. So you'll see molecular mass or molecular weight for things like water, right? Here is a covalent compound. So here's water, here's your H2O. And so you'd find the molecular mass of this, and it's going to be like 18.01 something something. But it's still a molecular mass, or sorry, it's still a molar mass. It's still grams per mole is what we're talking about. Only it tends to be just used for molecules and therefore just covalent compounds. That's all we're talking about. And then lastly, you'll hear formula weight, which is probably used the most broadly, aside from molar mass being super broad. Formula weight, you usually hear formula mass as an aside. You hear formula weight a lot. It's abbreviated FW. So formula weight, if you might see FW written somewhere. Formula weight is definitely used for ionic compounds. Because they are not covalent compounds, right? They don't form molecules because they're all individual particles. They're not covalently bound together. And so when you have an ionic compound, right, I have this picture of some generic thing. Let's pretend this is sodium chloride, right? Ionic compounds are these giant crystals, these giant lattices. And when we give the formulas for them, right, remember that you don't say how many atoms are in that crystal, right? No one says that, oh, the formula for sodium chloride is 10 billion trillion sodiums and 10 billion trillion chlorines. We just say it's sodium chloride, 1 sodium, 1 chloride, because that's the ratio of the ions. So if you look at this, right, the formula unit would just be one of the repeating sets, right? So this would be the formula unit. So formula unit, let me erase that. The formula unit is that repeating piece. So I circled here one of the purples and one of the greens because that's what's getting repeated over and over and over again, right? And you could go and find like, oh, here's another formula unit and another formula unit and another formula unit. And so when people talk about the formula weight, they're talking about the mass of that formula unit. hence why it's used a lot for ionic compounds, right? So this formula weight is the mass of the formula unit. And like I said, generically, this is used the most for ionic compounds, but you will see people use formula weight for molecular compounds too. It can be used for either. But it's fundamentally the same thing in that it is a molar mass. All of these things are given in grams per mole. And so they're used the same thing for all the conversions. It's just, again, atoms, atomic mass tends to be about atoms, molecular mass tends to be about, or will be about molecules, and then formula weight tends to be about ionic compounds, even though they can get kind of mixed up and stuff. All are molar masses, all can be used to convert between grams and moles. So they're really, really, really similar. They just tend to be used for different types of compounds, that's all. So I hope that answers that question. If you have any questions or comments, you can leave them down below. All right, take care.